Hello, scholars, and welcome to our Lesson 25, Session 3, on estimating the value of irrational expressions. So we got a friend here. I'm not even going to try his name. He's a member of a drumming group, and he plays this special drum that has a circular playing surface with a diameter of 6 feet. He wants to paint the playing surface with a special symbol here. The questions are, what is the exact area of the drum playing surface that he needs to paint? What is the approximate area? I mean, this is basically what our goal is here, is to be able to talk about the values, again, of irrational numbers, of irrational expressions. So let's dive in. What is the area of this? Well, it's a circle. The area of a circle, let's write that down, is pi r squared, right? So I guess we need the radius. So radius is halfway across here. So I hope you already know what the radius is. And it's going to be a radius of 3 feet. Okay, so the area of this is pi r squared. So pi 3 squared. We can obviously simplify that. 3 squared, or 3 times 3, is 9. And I'm going to write 9 pi. And what are we talking about? Feet. Now here's the really, I mean, that really has not much to do with what we're doing here. You know how to find the area of a circle. The real issue is talking about this number. Yeah? This is an irrational number. Is an irrational number, meaning if I write its decimal, or try to write its decimal out, the decimal will be ongoing forever and ever without repeating or stopping. But something special about this irrational number is that it is the only way to write the exact answer. This is the exact answer. There's no other way I can write this as an exact answer. The exact number here is 9 pi. 9 pi. 9 times whatever pi is, that's an irrational number, right? So if I want to express this as an exact number, I have to use that. And that's really important because we might be doing other operations down the road with something like this. And the sooner you round your number off, the sooner you change it to a non-exact number, the farther and farther your final answer is going to get away from the actual answer. So I almost always, when I'm doing math, I'm going to use the exact answer only. Use the exact answer only unless there is a pertinent reason why I have to use something different. But it is sometimes useful to have an approximation. So let's write approximation here. An approximation of 9 pi would be about, well, 9 times 3, I mean, it's going to be 27 something, right? We could do 9 times 3.14. We could do 9 times approximately 22 over 7. I'm just going to start by doing 9 times 3.14. And we get that. I'm going to write that as a decimal. We get 28.26 approximately. 28.26 feet. Now, for his use, this might be the best way to represent the area of this circle, right? He might not need an exact number. He just needs to know how much paint that he needs to get, right? And this number as an approximation might be more useful. Oh, you know what, friends? I forgot my squares here. This is area, so it needs to be squared. This might be more useful because maybe you can find a can of paint that will cover 30 square feet. And then that would be perfect. It's harder to get a feeling for how much paint he'll need when writing it like this answer. So there's really good uses for writing the numbers in both forms. And it just depends on what you're doing next, I think, with that number that's going to tell you what to do. I'm going to skip a couple pages. And we are on this page now. This first one says, why do you use pi rather than 3.14 to calculate the exact area? I'm just going to say because this is the only way to express this number exactly. Anytime you use 3.14 or whatever, you're not actually getting the true value of this, right? You're getting some approximation of it. It's not the exact number. But why might you need a numerical value for the answer? Why is it helpful to approximate? I think so just to get, whenever we need to get a better idea, oops, I need to, a better idea of where an irrational number is located on the number line. Whenever we need to get a better idea of where an irrational number is located on the number line, it's really helpful to use an approximation, to multiply by 3.14, to look in the calculator and take the square root of an irrational number, right? Because that helps us place it. That helps get us an idea of what we're talking about. We've already done this. We're just going to skip number 3. Use a calculator. You can use a calculator to approximate some irrational numbers. For example, many calculators use this 3.141592654 as an approximation of pi. Would using the value of pi be more accurate? Would using this be a more accurate final answer than using 3.14? I'm going to say absolutely. Absolutely. It gives us more details. It's going to take the decimal even further. It's gonna break it down even more. I mean, my calculator, as does yours, has a pi button. Oh, I haven't used it in a while. Where are you, pi button? Oh, right here. So if I wanted to put in here 9 pi, and it's probably using this number, right? If I put in here 9 pi and push equal, it's going to show me 9 pi. It's like, I really want the exact number, right? That's why it keeps popping up like that when you put like the square root of 2 in your calculator. It's going to be like, well, this is the only way I can write it properly. But you can ask it to give you an approximation. Here's the approximation now. Earlier we said it was 28.26. Now even getting closer, well, technically now that we have more digits, we're saying that a closer estimation is 28.27 for 83388, right? Getting even closer to the exact answer, but we could keep playing this game and adding digits of pi all day long. We're still not going to get to the exact number without using pi. So how do you write the exact number of an irrational expression? You have to use pi. Use pi, or keep the radical. Keep the radical. Okay, that's the only way to do it. Some application problems for us, real quick. First one, put these on a number line. I love these. I love these problems so much you're going to see them on the quiz, okay? And likely on the map too, okay? Because, I mean, this isn't so bad. And I'm going to ask you to write these in order, but you don't even need a calculator for this stuff. I'm putting my calculator away. No more calculator. Because you know what approximately this is. If you need to get out your number line, do. The square root of 26 is super close to the square root of 25. So close, I can just say, you know, it's about 5. Right? It's just a little bit more. Where does the square root of 26 go? Well, it's right above the square root of 25, which is 5. It's going to be like right there, just above the number 5. Well, what is 2 pi then? Well, that's like 2 times 3.14. But I could even be simpler with that. It's basically like 2 times 3, right? Which is 6. It's going to be a little bit more than that because really we've got that 3.1415 blah, 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 right? It's going to be a little bit more than 6, but that gets me close enough. Just getting me close enough, giving me an idea of what this might be. Here's 2 pi, right? A little bit more. Maybe close to 6.5. I don't know. I don't care. I just want an approximation. I just want you to be able to put these in order. Sorry, I keep unfocused. We've got a negative sign out in front. But this is like a negative sign and like 3 times 1/3, right? Of course, it's a little bit more than that, but I mean, 3 times 1/3 is 1. This is like almost -1, maybe a little bit further to the left than that. But here it is, just breaking it down into simpler parts. Here's negative pi times 1/3. Finally, again, we got a number with a negative sign out front. This is super close to the square root of 9, isn't it? So it's super close to 3 with a negative sign out front. It's going to be a little bit further to the left, right? It's going to be negative 3.1 or 3.2. Is our negative square root of 10. And so if I had to put these in order, I'd put this, then this, then this, then this. That is something you'll need to do on our next quiz. Which of the following has the greatest value? I mean, we don't need a calculator for that again. This is going to be approximately 4 times 3 is 12. It's going to be a little bit more than 12. How much more? I don't know. 12.4. I don't really care. It's more than 12. Okay. This of course equals 12. This is between 3 and 4, right? A little closer to 4 than it is to 3. I'll call it 3.6. Yeah. And then this, oh, this is 4, right? Square root of 16 is 4 plus pi. So this is approximately 4 plus 3 is 7.14. Let's just call it that. Okay, so which of the following has the greatest value? It's easily that. Like, you need to be able to, like, lock that in. Okay, if you just do a little playing with it, 4 times 3, and a little bigger than that, you got to know that's easily the bigger number. Okay, thank you. I have a friend in the background. They just lost their mind for a second, but we are almost done here, so they're gonna hang in there. This says a yield sign on a highway is in the shape of an equilateral triangle, which means all sides are the same, right? But who cares? It wants us to find the exact area of the triangle. We find the area of a triangle by doing base times height divided by 2. Okay, so our base is 4. The area is equal to a base of 4 times a height of 2 square roots of 3, all divided by 2. Okay, well, this is easy enough. 4 times 2 gives us 8 square roots of 3 divided by 2. We can still do more. 8 divided by 2 is 4 square roots of 3. And now we just need to add units. Feet squared. This is exact. If we want an approximation, we could think about what the square root of 3 is. That's like a little less than 2. And multiply it times 4, but we can always ask our calculators too. 4 square roots of 3 is equal to 4 square roots of 3, right? Because it's an irrational number. But if I ask for an approximation, it's approximately 6.93 feet squared. And sometimes this is helpful. If I'm just asked, well, what is the area, I'm given this, right? If I'm applying this, if I need to figure out so I can put a coding over this or something, and I need to buy the coding, then maybe I'm looking at this number so I can read the label and say, oh, I need at least 7 square feet of this to make this work. Okay, that's all for this lesson. Let me know if you have any questions, and you should know what to work on next. Thank you.